So here we are, first proper video in the unit, working on stuff. So as you can see, I've finally got my engine here. So there's a few bits I want to do. I want to rescan bits of my engine. I've got to try and make an alternator bracket for this thing, which is going to be a bit custom. I really want to get the alternator nice low down and tucked somewhere in here, because a lot of them I've seen they're quite high mounted and it's not really what I'm going for. So I want to try and see if I can get the alternator tucked down. This is the alternator. I got this from a scrapyard. It's off I think it's a 120D. It's a 180 amp or 160 amp, 180 amp alternator. And that's going from, I think the original alternator on the car at the minute is an 80 amp alternator. But obviously I'm planning on going electric water pump, electric power steering, and a few other bits and bobs, which is going to draw a lot more power than what the original car was drawing. So I was actually only aiming to get something like a 150 amp alternator, but I stumbled across this BMW part. It's easy for me to get in the UK, which is a big thing, which is why I went and got them from a scrapyard in the UK. So yeah, that's the alternator. I've already actually scanned the alternator, so I won't be doing that today. But what I do need to do is get the crank pulley on, which I have painted off camera. So I want to get that on, get the engine scanned, particularly this sort of area. My initial thought was to have the alternator here, but I think with the dipstick, it's going to be a bit too tight. And there's no actual reason why I don't put it here. So yeah, let's get on with that. First job, get the pulley on. I did have to order a tool. I was tempted to drag it on with the old bolt. I have got a new bolt, but I read online that you could potentially strip out the threads in the crank, and I didn't really fancy doing that. So I thought I'd buy a tool which was, I don't know, 10 or 15 quid or something, which could potentially save me many monies. So yeah, sometimes it is best to have the right tools for the job. So with this tool, it's just a case of threading that bar in. So it's got a nut, as you can see, and it just have a bearing. So when you're tightening it up, it allows the nut to spin easily. If I can get that actually in the camera, well done. So yeah, the bearing just allows it to spin, but the washer, the piece that's going to be sat against the crank pulley, doesn't spin. The idea is to bottom this out, the actual rod out in the crank, and then once that's bottomed out, you then wind it in with the nut, and that will pull the crank pulley in nice and straight, and hopefully no damage to crank. Oh, that's what happens when you buy cheap tools. That bearing's just collapsed. Yeah, when I say collapsed, it's, yeah, no longer really a bearing, to be honest. All the balls have shattered and all sorts. And you never want your balls to shatter. Never. You can see I don't know if you can see all the balls falling on the floor. So, I mean, it's most of the way on. I think what I'll do is drag it on the rest of the way with the old bolt. Turns out when you buy a cheap tool, they're only a one-use tool. Oops. But I think it's done the job. It's got it on most of the way. It only needs to go on another couple of mil, I think, so like 4 or 5 mil. Where's the old bolt? Yeah, so I'm just going to use the old bolt, and then I'll go on with the new bolt in a bit. So you throw that on the floor if you were wondering. It's definitely gone on more. So let's have a little look, see how she's sitting. That seems to be fully seated. I've decided I'm not going to put the new bolt in yet, mainly because I've not brought a torque wrench with me. So what I'm going to do is do my scanning, what I need to do now, with the pulley on and everything, and then, yeah, go from there really. So what I've got here, I think, is enough scan data. I've got my 4 points that I would like to utilise as mounting points, and then I've also got the 2 pulleys, 2 bits on the pulley, which I know they're not in the best detail, but at least it gives me a position reference, which is what I'm after. So I can use that as well as my scan with the alternator to align it all up, because I've also got obviously the pulley on the scan data. So hopefully I've got enough there to be able to at least make some initial designs. So I've done my scanning now, we're sorted with that. I'm going to hopefully be able to design something up. But what I did notice as I was moving all of my stuff from my garage to the workshop is this is what was the bracket that held the AC pump, and it has a tensioner. Don't know if you can see that. So what I'm thinking is I want to quickly whip that off, give it a quick clean, take that home so I can maybe use it to design, incorporate a tensioner into my bracket, because I was initially going to do something that I tensioned it with a rod or something like that, but I think I'd rather the alternator be bolted on fixed and have a tensioner of some sort. And yeah, maybe we'll go with something like this. I'll take this off and use this as a baseline. I can always change it. It's the beauty of designing stuff on CAD. Can do a few iterations now. And the last thing I just want to check out is, so I've now bought a 3D printer. It's not in here, it's at home. And I've been messing about with it a lot. I've got the Bamboo Labs P1S. It was on a Black Friday deal. Bought it, been using it quite a lot. I'm really impressed with it so far. I've done quite a lot of prints, printed some of my designs and stuff like that off, which I've only brought one with me today. That I just wanted to test fit and make sure my geometry works and stuff like that. What I've brought is an updated version of my water manifold. So since I've bought this 3D printer, I've been doing a lot of research on materials and stuff like that, and I've found some materials that can hold around 200 degrees, which should be able to work to have the water manifold 3D printed. And I think I'm going to try it. So I've 3D printed, this is just printed out of ABS, just first initial prototype of one that's going to be 3D printed. As you can see, I have put O-ring grooves in it. It's printed out of ABS, and so far it's printed amazing actually. It's one of the best prints I've managed to do. There's a few layer line issues and stuff like that which still getting to grips with the settings and stuff, so it's bound to happen. Obviously you'll know that if you've watched previous video, I already have a prototype for a water manifold. This one was designed to be CNC'd. I got it 3D printed as a test print. I have made a few slight iterations on it because the bolt holes were slightly out. But since, like I say, since buying this 3D printer, I've been doing quite a lot of research on materials. And I was under the impression that the only high temperature material was a material called PEEK, which is very expensive, and you need a very expensive machine to be able to print it. Where there's some, I think it's carbon fibre nylons or something, I'll throw them up on screen in a minute, that should be able to hold about 200 degrees. And I think I'm just going to give it a go and see if that will hold, one, the temperature, and two, the water pressure, which realistically isn't that high anyway, 1.6 bar or something like that. So if it's going higher than that, we've probably got a bigger issue on our hands anyway. But yeah, I'm going to test fit this, make sure the bolt holes are right, bolt holes line up and what have you. And we'll get a little visual representation of what it could look like. So it is bolted up loosely, and I think it looks pretty cool. Something a bit different, no contacting issues, nice bit of room around it. The only issue I do have at the minute is my bolt holes. I don't know if you can see that, just slightly out. These two are under, this one's alright, this one's under a little bit of tension. So I just need to move this one up a touch, that one out a touch, which isn't too much of an issue. But yeah, I think that is a little bit of an improvement from the other one. So it's been a week and I've used my scan data, which you'll have seen, and I've designed my, let's say, version 1 of the alternator bracket. So obviously these 3 holes, 2 here and 1 here, will mount the bracket to the engine block, and then those 2 holes are to actually mount the alternator. To start with, what I've done is just have it so it's going to be bolted directly to the block. There's going to be no adjustment on the alternator, and for now there is no tensioner. So I did say that I'm going to build a tensioner into it. I've since cleaned it up, but I've not designed anything for it to work as of yet. I want to do a quick test fit with this, make sure the alternator fits to it, make sure this fits to the block, and then I'll look at building the tensioner in, if that's even possible. So yeah, without further ado, let's give that a little go. So the first thing I've done, I've made the bolt holes the wrong size. So I'm going to drill them out a little bit so they fit. Right, I've now drilled them out. Not the prettiest, but I just need to open them out to 10 or 10.5 mil. So let's get that bolted in. So as you can see, that fits up to the block, lovely. You might notice that I haven't used this hole. So what my thinking was, I'm going to try it like this for now, see if it requires an additional bolt hole. And if it does, then obviously I'll stretch it out to this point. But I'm hoping that I can get away with it with just these 3 mounting holes. Especially once it's made out of either aluminium or steel. I don't think it'll be an issue that it's only these 3 mounting bolts. But yeah, I suppose we'll find out, won't we? But it sort of fits around the block, nice and flat. Around the hole. I'm pretty happy with that. So the next thing is alternator. The alternator bracket is now installed. I did think I had brought the alternator bolts when I bought the alternator. I thought I'd sort of put it in with it, but I don't seem to be able to find them. So I'll just have to pick some more up when I get there. The idea is that I do use the original alternator bolts, but yeah, we'll fit her up and see how we get on. See if I can do it with some smaller bolts. Just needs a tiny little tickle with a little belt sander, and I'm going to do it on the back edge because the front edge is more important for my fitment. So, as you can see, alternator's on. I don't quite have the right size bolts like I just mentioned, but it does fit up pretty nice. You can see there's a bit of play there, but that's because it's not the right size bolt. If that was the right size bolt, it would be fine. But we seem to have... I had to sand a tiny bit off the back like you saw. I'll just take a mil or so, like around a mil off the design, which is a 2-minute job. And that should mean that the actual alternator bracket is pretty mint. Fits up nice, no major contacting that I can see. And as you can see, line those ribs up as best as I can, and I'm pretty sure that's going to be close enough alignment wise. Well, I suppose we'll find out. If it starts spitting a load of belts off, we'll know I need to adjust it, but I'm pretty sure that's right. I lined it all up in the CAD software, and everyone knows it must fit in CAD. If it fits in CAD, it fits in real life. That's like the rule, apparently. But yeah, I'm pretty happy with that. Sits nice and low. The only thing, before I go too far printing a load and getting one made, I just want to make sure that that doesn't contact the chassis leg or anything like that. But I just think that is going to look much tidier. Instead of having one slung up here somewhere, it's all up on that side. Keeps it down low, keeps it tidy. And like I said, I think I'm only going to be running one belt on this, literally the alternator belt. So I'll have the tensioner. I'll see how I want to tension it anyway. I'll got a bit of figuring out on that side of things, but this sort of proves that the alternator bracket works, apart from a few little tweaks I've got to do. So yeah, great success.
Great success.
So I'm not sure if I'm going to end the video here or not. And if I do, I hope you've enjoyed the video. And yeah, there's going to be quite a lot of videos coming thick and fast now, because I've got the car in the workshop. So I'm hoping there'll be a video with this actually sitting in the engine bay soon. Obviously I still don't have a gearbox, but blah blah blah, I'm going to go on about it again. If this does end up contacting the chassis rails when I test fit it, I do seem to have a bit of movement. I can probably go 10 mil inwards, and I can probably go a little bit higher. So there is a bit of movement in that, which is quite nice. But yeah, really happy with that, especially since though I scanned it, I've designed it, and I've printed the test piece, and it all seems to line up nicely. So like I say, if you enjoyed this little video, it's a bit of a itty bitty video about me 3D printing a bracket. It's not the final version, but I just kind of wanted to show you the beauties of a 3D printer, in the fact that within a week, and that was printed, I printed it on Monday night, and I did the scan on Sunday, I printed it Monday, so I could have fitted it Tuesday, it's just I've not got down to the workshop. And that's the beauty of 3D printing and 3D scanning, is the fact that you can prototype these things and you can make these things on more of a hobbyist level now, where stuff like this used to be like you'd only be able to do in industry. So it's quite nice that we can do this sort of stuff. Yeah, I'll stop waffling. Give us a like, consider subscribing, and yeah, the next video is probably going to be a good one. if I've not put that video out before this one. We'll see. I might put them all out at the same time. That'll mix everyone up, won't it? Loads of videos for you to watch of me. How exciting for you all. Anyway, have a nice weekend.